Good evening to those who are in the UK and morning to those who may be closer to where I am in Pacific time. Wherever you may be, welcome to this talk. And this is an op honor and an opportunity to kind of step back and take a look at some of the critical decisions in AI. And I think one of the fundamental questions we have to ask is, um, can algorithms do all that we claim that they can do? And I'm going to bring this to you from a point of view of more than 50 years experience in the application of AI to significant problems, and then that have been deployed into actual trusted systems, working with everything from the nuclear power industry to NASA to areas where people have actually built systems that employed some form of computational intelligence. So that's kind of the context and the background. In looking at that, I think what we have to do is I'll get into the context overall of AI, but over the last few years, we've had a tremendous amount of promise. And I heard one CEO of a large language model company yesterday say that every one of these data centers contains 50 million Nobel laureates, Nobel prizes. And the question is, are the algorithms really that powerful, or is it time for us to take a deeper look? And this is not to negate all the progress. It's just a question of what is the right way to use it. It isn't all the progress is that is there and real is real, but we have to look at promise versus actuality. So the wake-up call I want to point out here, and it's coming in various forms, and there are various interpretations to this. You've probably seen the article that was circulated about 95% of agentic AI experiments have not succeeded. This is another. This came out somewhat recently from surveying 5,000 employees. It showed up in the Wall Street Journal. McKinsey has reported on it. And basically, it's this, is that the expectation and the performance are not there in a very significant way, enough for it to be a major wake-up call. The forecasted earnings that have to be done by large language model companies to actually give a return to their investors is um, not being supported by sort of standard techniques. So we have to say, what can we do? I think there's actually a very positive answer to this problem, but it does require a fundamental shift in our understanding of where the intelligence comes from and how do we best use this as a way to create both corporate productivity and social progress. The generative AI paradigm is that we can learn everything we need to know from algorithms applied to our data history. And that's all it has, by the way. Any intelligence in it is attempting to mine crystallized cognition, bits of ideas from documents that both have truth and error in them. The algorithms are partitioning through that, and these models are aligned by humans using them to say, is that good or not? But the only thing they're trained to do is generate what is plausible, not necessarily what is true. And that's great. I mean, so first of all, think of this as a really, really cool idea engine or a plausible engine. And it can even do things like magically produce something like AlphaFold. I mean, that is all true. On the other hand, when we get into trust and how we operate our organizations, it becomes a whole different matter. We can't make decisions about very, very critical things without a different form. And that requires trust and transparency. And that requires thinking about AI differently. And I was part of a small team that over 10 years ago took the same technology, transformer model technology, which appeared on the scene 2016, 17, working with some, PhDs out of Berkeley and a very strong background. We looked at this and said, what if we can apply this to how we think together and imagine futures together? And specifically, we took it into a very specific experiment which I'll talk about later, a 4-year experiment. And can we predict what startups are going to win or not? Very significant problem in human judgment because there's no data that gives us the intelligence to do that. So that's what the GCI paradigm is, literally a unique and different way to use the same technology, but it learns from the data of our working together, our thinking together, and it works as an aid to our thinking together. It decides with us, not for us. So the paradigm shift is AI is not an answer machine, but it is a exoskeleton to help us learn, think, and act together. And so that's the way we want to think about it. Think of it as a operating system or a supervisory layer that guides and learns and reflects how we're learning together. It amplifies human capacity rather than replacing it. It doesn't try to extract and use, it amplifies. It reasons with us rather than for us. All of you have probably had an experience where you trusted the reasoning power of an LLM and were sometimes amazed at how cool it was, but other times profoundly stupid. And there's examples everywhere about that now. And this is not something I want to talk. I'm not an naysayer by any means, but we need to reason with us so we decide what's relevant. So if you think about it simply, what generative collective intelligence simply says, of all the stuff this thing's generating, what's relevant to the problem? That's it. And it continuously learns, adaptively learns as a collaborative assistant. So here's a key thing. The data you left behind, does that capture all your intelligence? I've asked this of many people, and you sit there and think about, of course it doesn't. If I have a critical decision, do you want someone to just say, hey, here's all the stuff I've said before, you can figure out from that? I don't think there's an algorithm that anyone, by the way, algorithms are created by us. And this is sort of saying that we somehow can figure out how to take the data and make something better than us. I don't know that that's a good proposition. The other opportunity here with generative collective intelligence is to say, how can GCI work with human intelligence, not as a replacement, to enable us to build a trustworthy path forward? And I believe that is the future. If you take one thing away from this, it's shift the focus from the AI as the answer machine to AI as the collaborator with us to make a better world for us. So the hard problems are where the acid test comes in. And this is where, if you look at anything you're getting into now, uh, what are the hard problems that we really need to solve? Well, for one, AI itself has raised a concern about the future of work. Can AI, in fact, be flipped around to be for a better future for work? And we've seen recently some in the New York Times, a lot of money being thrown at that hope. And that's part of what we want to, and this is the thing that we've been working on for the last 10 years, is that all trusted intelligence is peer reviewed. This is the scientific method. This is what we've been using for hundreds of years. It is actually part of our judicial system that we collectively peer review and try to come together with a judgment that represents something that is trusted and valued and can be taken forward. This is the sort of thing we need in terms of looking at problems in healthcare, mental health, educational transformation, public policy, environmental issues, etc. So how do we find common ground? Well, it's a kind of a difficult problem. And one of the reasons we've often avoided it and gone for the strong person hypothesis that this is so big that we can't do it ourselves, let somebody who's super smart try to solve it. It doesn't always work well for humanity. Um, and also, and this has even gone into, the past prior to the Enlightenment, that religious leadership could somehow decide for us the path forward. That doesn't work. What has worked is when we collectively come together. But the problem is it creates a communication complexity problem. that even if you have 20 people, you got a couple of hundred lines of communication you have to manage and it happens in series. We can't operate in parallel. We operate in time. And so it's an intractable problem. In fact, Arrow's impossibility theorem, it basically states that you can't please all the people all the time. There's no voting system that works. Now, here's the thing that is now true, and this is what we've discovered over the last 10 years. It can work, and it does work if you apply AI technology to that particular problem. How can we listen broadly and deeply and learn together at scale? That is the big insurmountable barrier that has been broken down. It's even bigger, in my humble opinion, than understanding how to extract intelligence from data, enabling us to communicate together and apply this notion of shared trusted intelligence is the big idea that we can achieve out of AI. Now, there's a rich scientific foundation for this. And my PhD was in magnetism, applied physics and magnetism, understanding how order emerges from what appears to be chaos and all the mathematics associated with that. Well, last year, Hopfield got a Nobel Prize for taking the mathematics of how magnetism works and applying it to how the human memory works. And that is work that went on even back to the 70s, about the time I was doing my PhD. There was a guy named Little at Stanford who picked up on that idea. Hopfield picked it up and then took it forward. And then more recently, it has been well established that deep learning works because of its attachment to this physics principle of cooperative phenomena and something called renormalization group. And I won't get into that, but here's what I can tell you. That can be applied to the communication problem. How we communicate to each other, we can learn the emergent beliefs of a group as they're being formed, as we deliberate, as we talk, as we share information with each other. We can use AI to learn what our patterns of alignment are, and this can help us guide together. Now, there are other principles that come into this out of science, like the free energy principle. It's a very different model for AI. It's a living systems model for AI. It's one I particularly I'm on the scientific advisory board with that, and that's a very big part of what we won't have time to go into the underlying tech today, but know that there's a deep, deep body of scientific research here. This is not a company or an individual coming off with a crazy idea. This is something that's fundamental. It's part of how biology works, how living systems work, and we can tap into that particular thing. Now, what we want to do is represent this in a system that we'll call it the collective reasoning. I'm a little, I don't like the idea of throwing out operating system, but in a sense, an operating system is an organizing system. I mean, way, way back on PCs, it was how you organize your files. And this is how we organize our thinking. And this is what we've been working on for the last decade or more. But a collective reasoning agent that is like a super facilitator, an operating system that helps us reason together with each other and then reason together with large language models and AI agents. And what it produces is automatic knowledge acquisition that takes the aggregate of our intelligence, the intelligence coming out of AI agents, and creates a new layer of intelligence that shows up in things that look like an AI model that you might see in a chat GPT, except that what's different about it, it's highly contextualized, highly trustworthy, highly explainable, and can be tracked against ground truth. Now, how it works is you simply pull together a group of subject matter experts, and that's important because this isn't going to do magic on the random crowd. Um, it can work with a crowd of any size, but you have to think about inputs, outputs. But if you're bringing together a group of subject matter experts about a topic, and we'll give several examples on that, and together with AI agents, if you wish to bring them in, it's not a requirement. you can then create this thing we call deliberation or a collaboration, or I like to call them a jam. It's like a jazz session where people are interacting with each other, but the AI is guiding, observing that into a product that says, okay, here is a model of what you're talking about. You can talk to it. It actually retained all the knowledge associated with that discussion, but more so, it retained what was relevant to the outcome. It retained highly contextualized, highly meaningful knowledge about that interaction. It represented what it could extract from that as the prediction that was being made by the group, saying this decision has got a 70 some percent probability of working. In this particular case, it's pointing to an investment in a startup. And then it also has a rank ordered distribution of what was relevant, what knowledge led to that prediction. And this, by the way, is set up in a way that you can export it, import, export into other systems. Now let's talk about three hard problems that we can apply this to and has been applied to. Problem number one is, and this at the root of this, what motivated this is, can we create an AI-based collective intelligence and AI scoring system for investing in innovation so that that score represents the probability that it will have future success? And we'll just model success as survivable, meaning that on companies that obviously return on investment are survivable. And quite often, the rule in startup game, if you can stay alive, your probability of success just keeps increasing if you have a good proposition. So that's what we want to determine. We did this for 4 years, raised a small fund, pulled together subject matter experts around each startup, put them through a collective reasoning process governed by this kind of technology, and it emerged as we built it out. And what it was able to do is create scores for about 100 companies. And again, this was not a control group, but of those 100 companies, we found ground truth that within 18 months after the initial prediction, we were able to see whether or not they were actually able to raise money. So it's a small measure, but it was highly accurate. It was better than 85% accurate, better than 80% accurate, we show here, a little more conservative. I mean, the numbers vary depending on how you look at it. And then the big thing was it removed systematic bias to a great degree. Particularly at this time, this was on 2016 and 17. The general situation that was that female-led businesses just simply didn't get attention. Quite often, it was very hard to get that happen, or any minority-led business. Um, and and so this basically showed that the scientific method, which is what this was, applying that to this decision process, it worked to reduce systematic bias. Now, the top scoring company has actually gone on to be a position to be a unicorn. It's approaching $1 billion in valuation 100 days after the initial valuation. It got funding a Series A led by Intel Ventures, and then Microsoft, Amazon, a number of other companies came in, and it became a leader in neural decision chips, neural information processing chips. In other words, it runs a deep learning model on its chip that runs on a hearing aid battery. What came out of the deliberation session was a redirection of the company from a niche opportunity in hearing aids to a broad opportunity in speech and a variety of other cases, which led to its current success trajectory. And it's positioned to go uh, public in 2027, do an IPO then. And this is data that we still have that persistent model and data from 2017 when the decision was made. So that's another thing to keep in mind here. You can keep a record of what predictions you're making about decisions or investments and then see what you learn. Second hard problem. Can you transform an industry? What industry needs to be transformed? Well, it's biotech. It's one of the only industries where the group it serves, supposedly, is not the customer. The customer in biotech is the provider and to some degree, the investor. So it's highly tuned to return on capital, not tuned to the return on patient health in a broad sense, in a sense, global health. Therefore, we're being strangled by the cost of healthcare in every country. This is not, I mean, people have tried different systems, and healthcare is an issue in many, many countries in terms of how we manage it. Well, can we change that by pulling together patient care groups, industry groups like CEOs of biotech companies, academic institutions, government, payers, bring that all together into a deliberative session over few weeks, months, where we use this kind of technology to decide how do we turn this around to it's being sponsored by the 90/10 Institute, which is basically about basically this current system is serving 10% of the most profitable disease types, and we need to have it serve all of us. So, can we do that? And the breakthrough idea here was that why don't we treat patient care as an asset class so that the investment motive, we need to have an investment motive. We're not trying to say you don't, but can we do a more intelligent investment motive that rather than treating patient care as an expense, we treat the patient as the customer, we involve the patient more frequently in it, and we treat the patient as an asset class. So, are these investments leading to greater longevity, greater reduced costs for healthcare, and greater health for the global community? And that's what we did, and we came up with a blueprint, and basically this created language models and causal models, and it was came out as a blueprint on what are the core principles and what's a rough implementation plan. And this is now going into the next level of how we might take that forward. Third hard problem, diplomacy and defense. And this is probably the one that scares us the most, is that somehow AI will either get into the wrong hands or take things over on its own and cause our demise. And so this was something that we did. I cannot talk in great detail about this, but I can talk about something we did at a conference September a year ago, last September a year ago, at the NATO Open Innovation Conference and Exposition, where we did a war game scenario, even then, of bringing AI agents together with human beings and decide, well, can we make a decision that is a trusted decision that where we're able to determine whether the AI agent, whether the information we're receiving is true or false. And this can be applied, by the way, to cognitive warfare, all kinds of things. But what we were dealing with here is we don't want AI autonomy to be left alone. So humans must remain in the loop, and it must be done at the granular level of considering the evidence, playing Sherlock Holmes here, as what is the right outcome we should do? Should we counterattack or not? And so it also creates a system of record for how that decision was made. So this is an example of another hard problem that we can address with this technology, and it is being addressed today. So now let's talk about where does this fit in the big AI picture. AI has been around ever since we invented the digital computer. We started figuring out how to play chess and do machine language translation, going back to like the early 50s. And so this is ever since we had computation, we began to think about it. How can it be applied to human knowledge? And the first wave that really took its peak in the 80s was something called expert systems. And I was one of the pioneers in that category, being recruited by one of the founding fathers in that category, Ed Feigenbaum. And if you really want to dig into it, you look me up way back when in 1984. I was on a Computer Chronicles television program with John McCarthy and Ed Feigenbaum, where we're actually applying AI to diagnosing failures in a nuclear reactor. Why was that trustworthy? Why could we do that? Was it generating plausibilities? No. It was actually executing a decision-making scenario as determined from interviews with experts who were experienced and understood the details of what you need to pay attention to. And these systems were explainable so that you could put it into the machine, into the AI system for reasoning, and then the expert would look at the reasoning process and say, yeah, that works. Okay, so that now we have something that is trusted because it passed the review of experts. All trusted intelligence is peer-reviewed intelligence. And that worked. And there was involvement with the Atomic Energy Commission, NASA, another, and there are many systems that are deployed today. In fact, the way inventory seat management happens, I mean, before that, in the early 80s, airline tickets had a price, point A to point B. Then we had dynamic inventory pricing that came in. Guess what? We were a company that helped build that first system based on how do people think about managing inventory. And that then propagated into the rest of the industry. So that's a trusted application that we all get either benefit from or are victims of it. The next wave of AI was in statistical learning. And that is a very, very different paradigm. This technique was available in the 80s, but not enough data was there. But as the internet produced all this masses of data, suddenly this technology came alive and began to be very, very useful. And deep learning became the key thing, how we can learn patterns from data. Extremely powerful and scalable. The first one was not scalable. This is highly scalable, but it's black box and it's not trustworthy. And it cannot be trustworthy because we don't know how it is working. We can minimize the potential risk, which is being worked on today, but the risk will never go away. Now, the risk doesn't go away even in subject matter review. I mean, trusted review, but it's much, much a more auditable and controllable problem than dealing with a probabilistic engine that we don't know what it's going to say. But it can be pretty good. But if you even think about things like AlphaFold, how do we know that? We had a subject matter expert review it and say, yeah, that's good. So this is what we want to take for the next wave. This is a wave that began in some roots of this technology 10, 20 years ago that is now becoming highly relevant to the future, which contextual adaptation, how do we use this in specific situations in our organizations, in our society, and how do we fuse human and the digital capabilities together to create something that's scalable, trusted, and transparent. That is, in my point for this, the critical decision we need to make about AI is this is the future. This is where we need to be placing our investments and attention. So why GCI now? Because agentic AI is here. We have we have a wake-up call. It's not exactly working, and the reason is trust. It is also not focused on organizational collaboration. Everyone's talking about it now. 10 years ago when we started this, nobody was talking about it. And everyone's talking about it now. And we have an opportunity to build a system that is trustworthy, transparent, and provides oversight that we can have a brilliant future ahead of us. So the paradigm shift is for the common good, not for necessarily the good of the AI systems and their machines and or profitability. Profitability is good, but our common good is more important. We cannot destroy the environment in order to create a great AI engine. And besides, to help us, we need to work together on issues like global employment, industry transformation, and defense and diplomacy. And with that, I'm going to say thank you. And I hope you get the basic core idea here is there's a very different way to frame AI so that it amplifies the best of our human judgment, the best of what enabled us to create all the great things we've done so far and amplify it into the future. Thanks again for the opportunity.